Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. So it's the third part of this same problem, body on incline. No friction. So we have body on incline, we have angle alpha, we have N, we have mg. No more forces, we have the sum of all forces equal ma. We put this mg plus n equal ma. We put x, y, or put x and y that way. Bottom line, we receive acceleration this direction. And this is g sine alpha. And right now they're asking us few questions. First of all, they tell us that body starts h, height. This is the height that body starts 1 meter. And they want us to find the time, and they want us to find the speed on the bottom in this situation. And let's do that. So let's draw this a little bit. So this is h. This is alpha, and this is the length, the distance that the body travels. And we know, I will not be solving dynamics part here. Dynamic part is solved, and all I would be using is this. So we figured out that acceleration is equal g sine alpha. And it's fundamental, and it's very easy to not memorize, not to remember, but you will bump into this quite often when you will be solving those incline problems. Alright, now all they want us to find v at the bottom and time. So it's actually kinematics. It's completely different playlist, but let's nevertheless solve it. So first of all, we know that we're covering this distance, we're going with acceleration a. And this distance is L. And we start with 0 speed, so all we have to write pause. You forgot this formula, L equal V0, but V0 initial speed is gone, so L equal acceleration t squared over 2. L equal g sine alpha t squared over 2. But they don't give us L, they give us H. So we can write here that H divided over L equal sine alpha. So we can say that L, actually if we send L here, sine here, we will receive H divided over sine alpha. And of course when we send L here, it means that I multiply both sides on L. So I multiply by L and L is cancelled. But I multiply right side, L is on the right side. And then I divide both sides by sine alpha. Sine alpha would be gone, but sine alpha would be here. And all I did also simultaneously, I have H divided over sine alpha. I switch the side in one move, which may be confusing for you. But now I write L first, and this is what I did. H divided over sine alpha. Fantastic, I plug it here. Because L is unknown, H is known, so I put H divided over sine alpha equal g sine alpha t squared over 2. And now they want us t, so let's find t. That's quite simple. I have 2h divided over sine squared alpha equal, and g here equal t squared, and I can have here, let's put it, well, let's wipe it here because we don't need this anymore. I will receive time equal square root of 2h over g. And when I take square root, it would be 1 divided over sine alpha. And let's now use some common sense. Let's check that alpha, for example, equal 90 degrees. Remember, like I will increasing the alpha, and in the end it would be 90 degrees, and this would be h, and this would be L, and this would be free fall, acceleration would be g, and sine alpha on the bottom will become sine 90 degrees is what? Correct, sine 90 degrees is 1, and I have this, as sine alpha is gone, and t equal, without this, 1 over 1. Very nice. Let's imagine that alpha now equals 0 degrees. Well, that would be trouble. If alpha is equal degrees, sine alpha is equal 0. And I cannot write this. My mistake would be that L equal 80 squared, A equals 0. This would be 0. L equal, this would be like an applicable formula, because L with A is equal, would never be reached time. L, this part was always would be 0. So it will never cover this, and there's a lot, and this has a lot of things. This body stands on the flat surface, it will never move to the side, so we will never cover any distance. So all of this would be false, and this would be false, and this would be false, and moreover I cannot divide on sine alpha because it's 0, and I cannot divide it second time. So all of this would be inapplicable. But if I look on this formula a little bit differently, I say, let's put very small angle, like very, very small angle, 1 degree. Well, sine alpha would be small, but it would not be 0, and all of this would be applicable. And time would be very, very big. So as alpha becomes 0, time is going to infinity. It's a lot of sense, because if this is like a really very flat incline, then this acceleration g sine alpha is very small, because sine alpha is very small. But this distance is very big, right? Because it's the same h, but if this is alpha, this distance becomes very big, because distance is h over sine alpha, and time would be really, really big, so that makes sense. And so time will be big with small angles, and with vertical angles, when alpha equals 90 degrees, time will be maximum. So that solves everything about the time. But now let's talk about velocity. They ask us about velocity in the bottom. But then again, we have this, and this is kinematics, and velocity at the bottom, v, which is the main formula of kinematics. Pause. Yes, you guessed it correctly. Initial speed plus at, but initial speed is 0, and a is g sine alpha multiplied by t, and we just found t. We can plug it here, and v becomes g multiplied 2h g, and sine alpha, they will cancel out, because this sine alpha comes from the formula, and this comes when I substitute. So, and now g I go inside, so v equal 2h g squared over g. I just brought g inside this radical sign, inside the square root, and in order to bring it I have to square it. Then when I take square I can put it out, and v becomes 2hg. And it's all good, and I even put it here. The only question that I have, and I don't have immediate answer, but the question is that there is no alpha. No alpha in this formula. No alpha. So it doesn't matter which alpha it is, it's the same speed. And if you think about it, you can kind of understand. If alpha becomes smaller and smaller, acceleration becomes smaller, but times becomes bigger, and time is inverse proportional to sine alpha, but acceleration is direct proportional to sine alpha. That's why they cancel each other out and time becomes the same. Still, if you think about it, and if you recall the problem that we had about, and this is in kinematics 2D, I think, but you can find it out if you look through the playlist. When we have a body that's thrown under the alpha, and it is x and it is y, and it travels like a parabola, and this is h, the speed has no relation to alpha, and only defined by initial speed and h. And it's kind of the same thing here, initial speed is 0, but it would be 2hg, so it's defined only by h. And if you think about it, it should remind you about kinetic energy, mv squared, and potential energy, mgh, and those energy not free, they tied with the law of conservation of energy, and that's a big thing. I don't want to muddy the water here with this, but I say that this is kind of nice that this is like this, because it's not contradicts the law of conservation of energy that we will be discussing probably three or five playlists down the road, so you have to wait. But when we will be discussing this, you want to be notified about this, right? If you want to be notified, you have to subscribe and you have to click bell. And if you have questions, you're welcome to ask those in the comment section. Thank you very much.